Sometimes you gotta bleed to know.
The rolling kinetic energy of an object can be found with this equation. 1/2 mass times velocity squared plus 1/2 moments of inertia times angular velocity squared. This equation occurs because an object has both linear and rotational kinetic energy when it rolls. The first half of this equation represents kinetic energy. This energy occurs from the bike moving forward. The equation has both mass and velocity, which can be found using the equation delta x, or displacement, over time. The second part of the equation is broken into two parts: I, the moments of inertia, and omega, the angular velocity. The moments of inertia is the rotational inertia of a rotating body, and it depends upon two characteristics: mass, and how far the mass is located from the axis of rotation. Because of this, the equation can be changed into I equals mr squared, because a bicycle is a thin-walled cylinder with a central axis. The second part of this equation is angular velocity, which is represented by the Greek letter omega. Angular velocity is the angle of an object over time and can be found with the equation delta theta over t. The delta theta represents the angular displacement and can be found with the arc length and radius of the object. Delta theta equals s over r. This means the final equation for angular velocity can be written as s over r over t. Now it's time to substitute in all the equations we just talked about to create one equation which allows us to find the rolling kinetic energy of the front bike tire. This full equation means that we must find the mass, displacement, time, radius, and arc length of the bike wheel before we can find the rolling kinetic energy. Here, I have set up a meter stick on the ground and I'm standing on a ladder to time the bike tire as it travels 1 meter, the delta x, or displacement. This time came up with a result of 0.81 seconds per meter. The next thing we need to find the rolling kinetic energy of this bike tire is the radius and the arc length. The radius can be found by measuring from the hub of the tire to the rim, and the arc length can be found by measuring this angle with a protractor. I took the tire off the bike and brought it inside so I could weigh it. Now we have all the parts to find out the rolling kinetic energy of this bike tire. First thing we need to do is put in all the numbers for their respective letters. After I did this and did all the math, I found that the rolling kinetic energy of the front wheel of my sister's bike was 3.8 joules.
And it takes a song to come around to show you